George Makris said Kalispera. So we are about to start the second session, and nice to see you all here. And I give the floor to Dimitrios Makris. Dimitri, you have the floor.
Thank you. I hope the online participants can also hear me.
Yes, we can hear you. So.
Yes.
Okay. So good afternoon from my side as well. My name is Dimitrios Makris, PhD candidate of Aristotle University Thessaloniki at the Sustainability Engineering Laboratory. AUTH is also a partner in Neutron. We are responsible for the biogas working tasks, and what we were trying to assess is how we can integrate circular economy and its principles into our Neutron concept, and this is exactly what we're trying to present today. So what we will be seeing in the presentation is what are the current challenges of Kozani for the post-lignite phase. We're going to see how circular economy can address these challenges, and not only so combine by solving another issue that there is in the city and of course in the area, and not only in Kozani, in a lot of areas of Greece, how we can address Kozani's energy transition. Also, we will assess, so when we're talking about circularity and circular economy, we mainly talk about waste, how we can utilize, how we can bring back the waste, so what is being thrown out, what is make it valuable for us and for the project. So we will assess the current state of Kozani, of its organic waste, and of course propose this, showcase the scenario that we proposed in Neutron. Okay, so what is currently going on in Kozani? We've seen some issues for its district heating model, for its district heating system. We have an increased cost of its translated into the citizens. So citizens were forced to pay more in the district heating systems. They don't have any other solution because they're connected to the district heating system. For the ones that cannot maybe read the image below, or maybe don't know Greek, so I will try to translate. It's from the questionnaire that we gave out into the municipality of Kozani, and almost 60% and higher of the citizens that participated in the questionnaire said that they had to reduce the operation of the district heating system in their house due to the heating cost increase. This is something that we cannot take lightly, of course. Another issue is that the direct future that the municipality of Kozani has for its district heating system is it still has imported fuel, it still has natural gas, and it still does not provide energy security and, of course, independence. At first, we had independence, at least. We did have the fossil fuel of lignite, but there was an independence on the cost, of course. And another thing is the social growth, the lack of social growth that we have during RES investments into the local area. So when we have an income coming in, for the RES investments, we have a minimal percentage of it going back to the citizens, going back to the local economy. And of course, the short-term labor job vacancies that provide, let's say, fake socioeconomic growth. And when this bubble breaks, there is a lack of job vacancies in the area. So moving on. So what role does the circular economy play in the issues that we addressed earlier? In the Kozani problems, what we want to achieve with the circular economy, let's say, concept that we'll present in the next slides, we plan to, of course, reduce the CO2 equivalent emissions, because we don't only have CO2 emissions. When we talk about waste, we talk about methane emissions. Methane has a higher emission factor than CO2. We talk about creating a profit, constant revenue stream for the local entities, for the local citizens. We talk about promoting social economic growth, and of course, create a value to something that is currently not being utilized. So this is the waste. Moving on. So what we try and achieve through the concept is solving one problem that currently exists, but not a lot of people are talking about, which is the unutilization of the organic waste. When we have waste that is being not utilized, so it's being thrown into the landfills, for example, we have high emissions that are being produced. Of course, we have costs for this waste that are being, when we transport this waste into the landfills, this is cost. This is a high percentage cost. So we're talking about creating a solution to this problem and in parallel solving Kazani's energy transition problems. So the current state in which that we were given by the local partners of Neutron is that on the one hand, as we said, we have unvalorized, unutilized organic waste. We received input from local entities from the ADIMA and the IAC about the quantities that are currently being not utilized. This comes from agricultural waste, so cow and goat, sheep manure, to wheat straw. This is another waste stream is the sewage sludge that is currently not being, of course, to our knowledge, being utilized for compost, but not from the AIAC, so not from the entity that produces the waste or actually manages it. What is currently being done is it's been given, so they have some contractor utilizing the sewage sludge currently for compost. And of course, we have the organic fraction of municipal solid waste. This is what it's supposed to be thrown out into what we call the brown bins. So for those of you who don't know, the brown bins are the ones that being used for the organic fraction of the municipal waste. And in the to the right, to the left, actually, what we can see is that the conventional energy generation. So we currently have lignite phasing out, transferring into natural gas for our district heating coverage, and of course some peak boilers that being fed through oil. So what's the impact on this? Of course, for the unvalorized waste, we calculated the CO2 equivalent emissions. So this is why the reason I'm saying equivalent is because it's the methane produced from the waste being just sit and not being utilized. And of course, the economical impact, as I said earlier, we have an OPEX due to this waste being transferred and managed somewhere. So going from this, next page. Going from the current state, what we assessed in Neutron is having the waste that we identified, the waste quantities, into an anaerobic digester, so producing biogas, and burning this biogas into the thermodynamic cycle of the green heat module that we presented earlier, to produce heat for the city of Kozani and of course electricity, on which we can gain some profit. What's the benefit of what we propose? Of course, it's the utilization of the organic waste, so not waste, not define the organic waste as waste, but as a source, actually, to zero out the methane emissions and gain some CO2 emissions from the generated electricity and thermal energy. Of course, generate some profit for the entities for the stakeholders that will create the biogas entity, and some social growth inside the city of Kozani, so creating some job opportunities for the city. Now, what we identified, as I said, is the three main stakeholders that could include inside the biogas entity is maybe a potential agricultural organization that could give its waste into the biogas entity. We have, of course, the act that it's currently it manages the sewage sludge, and the municipality of Kozani, that's with the help of the ADIMA, manages the organic waste, the municipal waste of the city. So if you can go to the next. As I said, these are the stakeholders that we identified. What we can see here in the diagram is we separated the 4 digesters that we sized. The reason is because there are constant values that the electricity is being sold into the system depending on the type of organic waste that we have. So the agricultural waste has a higher selling point into the electricity grid rather than the organic fraction of municipal solid waste and the sewage sludge. This is why we combined the agricultural into 3 separate digesters, and we separated the other 2 into 1. These are the values that I mentioned earlier. So for the first digester, based on the laws, we found that 99 euros per megawatt hour electricity being sold from the organic fraction and the sewage sludge. And for the agricultural digesters, based on the peak, for the installed power that we have from the biogas plant, we have 192 euros per megawatt hour. Also in our analysis, we assessed a constant value of 38 euros per megawatt hour for the thermal energy being sold into the district heating from the CHP of the green heat module, on which the biogas will go in and feed the district heating and the electricity grid. Okay, so I just wanted to very shortly present the sizing that we did. So in the technical parameters of the biogas plant, we calculated all the technical equipment needed. We found some CapEx value for it, some operational value for the equipment. We calculated the initial investment costs that we would need to create civil engineering costs, the connection to the grid costs, of course, the salaries that we would need to have in order for the biogas plant to operate, what are the energy needs for the biogas plant, so electrical and thermal needs, and of course, what are the transportation costs. So I would like to stay in the transportation costs because this is a cost that already exists. So we plan on taking these costs out of the current stakeholders, so municipality, the IAC, and the farmers. So this is one of the benefits that the stakeholders will have in order for them to give the waste into the biogas entity. So they currently have some costs that would go to 0, and the transportation costs would transfer into the biogas entity. So as a general outlook, we look at around on average 15 million cubic meters of methane produced per year. This accounts to around 40 gigawatt hours of electric energy and 40 gigawatt hours of thermal energy. As we saw, based on the constant values that we saw earlier, we had around 10 million, so the ownership, the joint ownership that we assessed would have a form of an energy community. This means that only 10% of the income can go into the profit of the stakeholders. The other 90% could be utilized into the city of Kozani into some way. So we're talking at around 10 million euros per year earnings for the city of Kozani. So the way that we can utilize this, we can see in future presentations, and 1 million profit for the stakeholders, so the farmers, the IAC, and the municipality. And based on this conclusion, we concluded in a quite fast payback period, lower than 10 years, without any national or EU funding. So in a nutshell, what we have is the current state. The 3 stakeholders that we identified have transportation and management costs for the waste. We have environmental impact, so CO2 emissions, CO2 equivalent emissions being produced. And in the proposed scenario, we zero out the operational costs for the stakeholders. And of course, we add that 10% profit for them. For the environmental scenario, we zero out the CH4, so the methane emissions. And of course, we have some added benefits from the energy produced, generated from electricity and thermal energy. And of course, the important thing here is a social benefit, which is we calculated to be around 13 jobs created for the biogas plant, and of course the around 10 million euros calculated per year that could be utilized by the city of Kozani. So closing, what I want to say is the amounts of energy that we showcased for the biogas plant are minimal compared to the demand that the district heating has, compared to the electric needs that the IAC or the city of Kozani has. So this is why this is just one out of the many solutions that Neutron assesses, has calculated, and of course tries to synergize in order to achieve complete energy transition. This is it, I think. Yeah. Thank you very much.